Okay, today we're going to work on evaluating and graphing piecewise functions. Yesterday's lesson was on evaluating. We're still going to be evaluating, but now we're going to be a little bit more selective on how we evaluate because we have to get more points in a row and not random points. So let's look at how do you go about graphing a piecewise function. This piecewise function has two equations with two different domains. That means you must make two tables. In this problem, it says x is less than -2. Now, most students would think, well, you don't use -2 because it's not equal to it. But you have to put -2 in your table because that's where your hole is. To get started, your open circle. And so because you have to start at that open circle for less than and not equal to, you have to put it in your table. Numbers less than that are -3, -4. Now you may not need every one of these numbers in this table. So start by just maybe filling in 3. See what kind of numbers you're getting. If they're still real small, you can add some. Now this side we're going to put x plus 5 because that's the expression that we're calculating in this table. We're going to plug each number in one at a time. Like -2 plus 5 is 3, -3 plus 5 is 2, -4 plus 5 is 1. Those numbers are really small, so I probably could use a couple more. -5 and 5 make 0, and -6 and 5 make -1. So they're going down by ones, and that's because the slope is 1. So it's going to go up and down by 1 on each side of -2 if you were making a table of all of it. Now with our second equation, it has the equal to in it, so we're going to color it in with -2, but we're going to pick numbers that are bigger also, like -1, 0, maybe even more than that. But for this function, we don't need more than that because this is a constant function, and a constant function, there's nowhere to put the -2, so it stays -4 the whole time. So 3 points is plenty for that. This is a linear function because it's y equals mx plus b, so it's going to make a straight line. Now when you graph these, you're going to graph each table. So on this first table, you're going to start with that open circle on -2, 3, and then you're going to plot your other points, -3 up 2, -4 up 1, -5 stay at 0, and that makes a line that's going downhill and has an arrow on the end of it because it started at an open circle, so the arrow has to be on the other end. In our next line, we're going to start on -2, -4 with a closed circle. -1 is also -4, 0 is -4, so that's a horizontal line going to the right, because that's a constant function. Constant functions are always horizontal lines. Linear functions slant. Now my linear equation has a slope of 1, and my line is going uphill, up 1 over 1, up 1 over 1, so I know I've got it graphed correctly. So as we go through these, you may want to, take some notes on this so that you can have some examples to go by as you're doing your own. Alright, so in our next example, 0 is our important number in our table. We can see that each one of them starts on 0, but only one of them is going to be colored in. So for our 2x plus 5 table, we're going to have an open circle, or what we call a hole, on 0. Numbers less than 0 are -1, -2, and so on. Now if you're doing linear or constants, 3 points may be all you need. It depends on how big the numbers get. When you plug in 0 times 2 is 0 plus 5 is 5. 2 times -1 is -2, and 5 is 3. It went down by 2, so it'll go down by 2 again. I mean, I could do it again, and I could keep doing it, but really 3 points for a straight line is probably all you need. For our other one, 0 is going to be closed in, because it has to start on the number that's in your domain here. Whatever number is on both of them, whether it's open or closed, it's got to start on that number. You can't skip like on the open one and start with -1. So this is greater than, so the numbers are getting bigger. And we're putting it in 2 minus x squared. So 0 squared is 0. 2 minus 0 is 2. 1 squared is 1. 2 minus 1 is 1. 2 squared is 4. 2 minus 4 is negative 2. And 3 squared is 9. And 2 minus 9 is negative 7. So I definitely don't want to go any bigger than 3 because the numbers are going to get too large to put on my graph. Now you make your XY axis the size you need it. For example, in this problem, I needed to go all the way down to negative 7 and all the way up to positive 5. So I don't need a lot in the X direction, but I need a lot in the Y direction. But all of mine are the same size because I'm using grid paper with off the smartboard. But for you, you need to know how big to make it. Now, if I start plotting points, I'll start with the hole that's open with 0, 5. 1, 2, 3, 4, 5. There's my open hole. Then I go over to negative 1 and up 3, over to negative 2 and up 1, and over to negative 3. Hope I didn't go up 1, I went up 2. Up 1, and then over negative 3, down 1. And there's my straight line that represents 2x plus 5. It is correct because it's going uphill for up 2 over 1 for the positive slope. So now let's look at the quadratic. The quadratic starts on 0, 2 with a closed-in circle, 1, 1, 2, negative 2, and 3, 1, 2, 3, 4, 7, down. You can see this is half of a parabola. And so that last point gave that parabola a really good shape. It would have been a little harder to do it with just 3 points. So a lot of times parabolas need 4 if the numbers are fairly small when you start. Straight lines you probably could plot 3 or 4 and it'd be fine. Now in our next example we're going to have more than 2 expressions. And this middle expression, I want to talk about it first. Instead of having equal to on one of your expressions that are greater than or less than, you could just have an equal to. Equal to means you're only going to have 1 point, so there's no reason to make a table. X is 0 when it's negative 2 because that's a constant function. I have nowhere to plug my 0 in to get a different number, so I know my answer is negative 2. That's going to be my colored in circle and my only colored in circle. So for my tables, I'm going to take the first equation, 5x minus 2. I'm going to have an open circle on 0, numbers less than 0, negative 1, negative 2, negative 3. We'll see how much that makes. That will be fine, or I may not want all these. 2 times 0 is 0, from 5 is 5. Negative 1 and negative 2 make positive 2, that's going to make 7. Negative 2 and negative 2 make 4, and 5 makes 9. Yeah, I don't think I even want to go any higher than that because that's already getting pretty big. For my other equation, the last equation, 4x plus 1, we're still going to have a hole because this is not equal to, it's greater than 0, but we include 0 in the table because that's where the hole is. Then 1, then 2, and I might need 3 on this one, we'll see. 0 times 4 is 0, plus 1 is 1. 4 and 1 make 4, plus 1 is 5. That went up by 4. So these are linear. They'll keep going by 4. So I don't think I want to use 3 because I'm already up to 9. So when I graph this, we'll start with the linear equation, 5 minus 2x. We'll have an open circle on 5. And then you go over negative 1 up to 7, over negative 2 up to 9. And there's my straight line that I put my arrow on the end. Then the second equation, I just plot a point, 0, negative 2, and that's all it is because it doesn't have greater than or less than in it. Then when I plot the third one, I'll say an open circle on 0, 1, 1, 5, and 2, 9. And that's an arrow going up from 0, 1. So I have a piecewise function that's, if I left that dot off, there wouldn't be an answer at 0 because both circles are open. But that dot at 0, negative 2 closes it in and gives it to be defined. So now you've seen the whole entire lesson and can take the time to work the worksheet on 2.2. There will be 6 problems. If you need graph paper, I'll be sending you graph paper to do the lesson by, or you can print some graph paper off the internet. I am going to put the worksheet out in Canvas along with the link to this note, so you can, be able to do the worksheet or go back and watch the notes and be able to say, okay, I think I understand this, but I need to watch that number 3 again. So you'll be able to watch it as many times as you need, stop it and start it whenever you need. All right.